Yeah, thanks very much to Digital Jersey for putting on this event and the whole Tech Week. We should be a bit fresher, but it started for us on Friday night. We did the IoT hackathon. I was going to wear the hackathon t-shirt to big up the geeks. And I recognize a few of the faces here. But it's just this continuing thread where if you look at one thing in isolation, a lot of the things we've been doing have just been backed up by what the speakers have spoken about here, which is collaboration, not just doing point solutions, but opening up the full sort of data set. So we were lucky enough, so it has actually largely been like 2 hackathons in about 2 weeks. The data, it was largely, we got the call from Rachel, can we help out? And so it's been looking at this one, and then we did the hackathon. So it just kind of shows you what you can do in a very short space of time with a bit of collaboration, a bit of will, just asking for the data, which Andrew actually did, but also following again on from Ricky's points earlier today, which is treat it with sort of the sensitivity and be mindful of the security. So, and again, I'll just steal some of the stuff that Andy Stanford-Clark said yesterday. So when we first started this, you can just throw the data in and start to do great things, but you have to start at the right-hand side, which is your left, which is what is the question you're trying to solve with this kind of great data. So in the short space of time, and with the IBM guys sort of collaborating, and Jeff will come on, so I won't steal his thunder, we weren't able to do as much as we hoped for was, does the ambulance response time impact the actual patient outcome? There are so many factors in that within the short space of time, and it again leads on from yesterday, that if I am treated for a heart attack and the ambulance gets me in 8 minutes, I don't yet have a digital twin to replicate what would have happened if it had got to me in 6 minutes. So and Andrew also pointed out, when we got into this, it's quite the data, there's just so much and there's so many questions you can ask. So we kind of settled on the question in the end with what we could do in the time available is where is the optimum placement for the ambulances to meet their 8-minute need for the high-level category responses. And we actually sort of broke it down a bit further because I don't know if Pete's in the room, if he's here yet. So Peter Grady from the ambulance service, they already have 3 sites identified, so it's not quite as complex a problem. But we'll talk you through the solution or talk you through the scenarios. So what we do here is Ben will just talk you through, you get a raw data file, looks pretty boring, and again, sorry Andy, you should have just come up here and done this, but you have to touch it, you have to feel it, and the best way to do this is start to visualize that data, to actually keep asking those questions, what if, and actually answer them very quickly. And then we can work with the really clever guys at IBM, and they do the clever stuff that Jeff will talk about, where you model it and then actually do the predictive analytics. However, when we spoke about Jersey, we did confuse it with New Jersey, so Jeff will be talking about New Jersey. We're Old Jersey, bit of sort of joining up, this is what could be achieved given enough time and enough will. So over to Ben, who's just going to do the first part, and I'll just stand over here to talk you through what he did.
Hi everyone. So this is a quick extract from the ambulance's own performance data. So just to show you that I've not made these figures up, they kind of tether back to these. So the data we got was from their call systems. They have a management information system that tracks everything along the kind of process from the call coming in about the incident all the way through back to when they ended up in the ED department. For this kind of initial analysis, we mainly focused on the calls and the performance, which is full of categorization, GPS, all the resources involved with a single incident, all those kind of things. Just out of interest there in the audience, how many people have used the benefit of the ambulance in the past? 1, 2, 3, oh, so small amount, which is a good thing. So what we wanted to see is how can we improve the situation. So is there any data scientists out here? Okay, cool. So correct me if I go off in the wrong direction, but so we looked at performance in our own way. So When you look at the performance over the years, things are pretty good. The target is, red doesn't mean people have died. That's not a negative outcome. That is just where it hasn't met the performance. The actual goal set by the UK is 75% of the 8-minute calls. So that's what that's showing. So just get that clear understanding of, we're trying to get those green bars up to that dotted line, and that's the target. To get a sense of volume, you can see over the years, the number of calls, so these red and purple or category A calls, are increasing over the years. So this is something that's just going to become more stretching and more intensive on the existing resources. So at the moment, the ambulance service uses 3 during the day, so 3 proper ambulances, the big trucks that fly around at fast speeds, and in the night they run an operation with 2. So that's just to give you a sense of kind of what they're doing. Okay, so that's like the island-wide performance, but there is a concept of performance areas. So what that means, so this is not coloring by numbers, this is coloring by data. So you'll notice there's some kind of offshoots and things. That's not because I couldn't color in properly, that's because the data's a bit funky. There's some GPS coordinates sitting in the wrong places, that kind of thing. This is their definition of Jersey. So you have this kind of north green area, the east area, which is kind of beachy, and then the kind of west area, which is green, blue, sorry, and then the kind of main population in the south. When we look at the kind of incidents in those areas, there's a clear winner. The south has got significantly the proportion of the actual accidents that happen. Interestingly, so over time, you'll notice that the other areas aren't really increasing in their demands on the ambulance service, but certainly that south area is really creeping up there. So take note of that, take that in, because that does kind of cross with the next couple of slides. There's not endless charts. I will eventually leave these. So, oh, sorry, one more. So that's the shape of 2018, how it's growing. It's taking the same kind of shape, but obviously we haven't reached the end of the year yet. So this is where it gets interesting. So when we look at the south, so everything that's close to the hostel or close to those existing positions, so for those of you that have seen the ambulance by the burger bar, that's not because they're having a snack, that is a tactical position so they can go and pick you up nice and quickly. That was actually based on a previous study, which I don't know how they did it, we weren't shared that research, but they did look at the kind of routes around and tried to figure out some best placements. So you've got the burger bar up by Five Oaks and Town. And you can see that has a great coverage of the south. It was surpassing all the targets across the years there. And 2018 looks good so far. Unfortunately, if you live further afield, it is further away. So naturally, those targets become harder to achieve. So what we want to do here is really kind of maybe stretch them out a bit further or try and optimize some from the south performance and bring up the other areas. So you want to find that sweet spot in between to kind of give the most optimal solution for the island. So here's when we started to dig into the data. So one of my favorite tools is Power BI. If you haven't used it, it's fantastic. We started to heat map what was going on with these incidents. I'll explain more on that in a second. So the heat maps are important because the placements at the moment were done based on what we think is obviously the population density and also the kind of access to the rest of the island. But obviously you kind of want to place those ambulances in a location which is going to suit the masses but has that reach. So by looking at this heat map, you're able to kind of identify that across time and all the other factors we're going through in a second. The time analysis stuff we've looked into because during the night, obviously that 2 ambulance theory, we want to check is there evidence to support that decision. Should we have three running at night? If during the night the performance is low, we need to put that other one back into rota. So I'm going to brave a quick demo live, which is never a good idea. So bear with me and fingers crossed. Okay. Cool. So here's the calls map of Jersey. So at the moment it's just on 2017. There's nothing sliced up just yet. So notice a couple of the filters we have on already is this red category and the purple category. That's the category 1. So that's the purple ones are the kind of the most urgent ones you can get. So that's the case where somebody calls up, somebody's not breathing, the ambulance boots out the door before you even know anything about the situation and head there. And I think the red is similar dynamic, but they find out more details before they start setting off so they can take the right equipment. But they both have that 8-minute target. So straight away you can see there's a nice big hotspot in town. That makes sense. You've got the most population there, so there's kind of Can you see it that well? I'm going to hide this. Okay, so with this kind of open view of the world now of Jersey, we can start to ask it questions. So this is effectively kind of the precursor to modeling. So you're able to go investigate certain scenarios. What I've done is picked a few out that kind of interest me as we're going along. So I haven't spent hours and hours looking at this. I'd love to, but I've been doing other bits as well. But this is something we then give to the users to be able to explore before we start to model. So if we look, I can't go in too close because there are data privacy issues here, but we can start to look at the kind of areas in town and the hotspots and that kind of thing. So you can filter it into just the south region and see the hotspots across town. So if it's optimizing just for the town ambulance, that kind of thing. Let's have a look at the south. So you can also do seasonal things. So at the moment I've filtered on the summery months or the kind of hotter months out of the year, and you can start to see if there's any changes there. So you'd assume that people are by the beach, causing accidents by the beach maybe, and see if that switches and see if there's any differences there. And if we have a look, everything apart from town. So this is, again, this is kind of backing up what we already know. So we knew there was going to be hotspots in town. But then when I start to look at this map, excluding town, because town's quite kind of congested, we can start to see around the parish halls, those kind of popular areas, it backs up that maybe those areas where there's shops, pubs, people, parking, that kind of thing, you're going to get more accidents. And again, there's a large hotspot there, which I know is St. Bernard, but we kind of thought about that, and that's, you know, another, it's almost like the second populated area in Jersey. Other interesting, more granular things you could look into Friday and Saturday nights in town. So if we look in a little bit closer, we can spot the kind of the classic areas of the Weybridge and, you know, Snow Hill and that kind of thing, and we can assume that people are having a great time, and an ambulance has been called around. What else we've got? So just to show that we kind of expand the model so we can take a different perspective, rather than just focusing on just the red and amber, red and purple, we have the amber and green calls as well. So different nature, that might be falls or that kind of thing, so less severe, but still events are all the same. We can start to see some trends in those. So one of the things I noticed when I was trawling through this, there was a hotspot down here, and I thought, oh yeah, that's the co-op, those people go shopping. But actually when I looked into closer detail, it was a care home. So you could see that there are often hotspots in places you kind of wouldn't expect. So that's trying to learn from the kind of the visual representation on the heat map. Another thing I was looking for was trying to see during winter or summer, was there more accidents along the beach line, and there is a slight difference between the colours along the coast. Now, this is just for human interpretation. In reality, you'd want to look at this in a numbers sense and start to model it, but it kind of gets you familiar with the data set underneath. I'll quickly show you in detail this. There's another one. So there's different ways to map it. You can do it by kind of, this one's looking at purely performance, so there wasn't a clear, we can kind of see there's like a green glow in the middle. That makes sense. It's closer, so you're more likely to hit that performance target. This performance time is kind of a mixture of things. So you get the times of day, whether it's the day of the week, so you've got different traffic scenarios, that kind of thing. Again, the user can explore that and try and find some insight. So that's enough Power BI. I'm going to dive back into the slide deck again. No, you can do that. What do you want me to do?
So, as Ben said there, so this is just an initial sort of cursory look into are there any obvious patterns, but you can do so much more with the likes of the Watson platform, given enough time, and really actually get the data to back that up. But what we were able to do in this short period of time is see how optimum the actual current ambulance placements are based on an 8-minute drive time. And so what we have here, this one is the St. Helier placement. And these are termed isolines. So in 8 minutes, that one has actually got traffic disabled, but we can also pull the traffic in. And I think with Andrew, when you say it's, oh, wouldn't it be great to pull in the weather data? And anyone at the hackathon would have known, wouldn't it be great to pull in the road traffic accidents that we had access to at the hackathon? You could then, and what we did at the hackathon is you just build up the layers and you just build it up with open APIs. So on this one, for example, this takes no account of any road closures, any kind of accidents. You put another layer in there and then see what impact that does for Pete and his team in the control center where the actual drive time, so you could actually get the dynamic routing of the driving. So that's the main ambulance center, and you can see how far you can get in 8 minutes. This, given enough time, would have to be proved and tweaked with a model with the likes of Jeff and his team, but this is straight out of the box using the equivalent of the Google API. How far can you get in 8 minutes from there? If you throw the next one up, so the next site, this is the one which is the burger, and like Ben, I thought, pretty obvious trying to hide in an ambulance to have a cup of tea at the burger bar. They're designed to be spotted. But it's way more tactical than that. You can see the coverage there, and it goes on to the previous points, that if you like the beach, I love the beach as well, you've just got to sort of fend for yourself largely at the moment. So what impacts this sort of drive time? And then the third one is if you had to have a look, which is in the St. Saviour's. So the east of the island on an 8-minute response time gets really good coverage. If, for example, can you do the next one where it's got the overlay? If you actually put them all together, you've got a Venn diagram, and you can see on 8 minutes, visually, very quickly, and say the traffic mode, you could actually enable the sort of traffic mode. But you can see a large swathe of the island there that's not sort of covered. And where I live, and I like surfing in St. Juan's Bay, I'm really going to have to think about what I'm actually doing. But visually, for the first time, I've lived in Jersey all my life, I'm from Jersey. I had no idea, and I've called an ambulance out in St. Juan's. I can't tell you how long it took, but it felt like ages. So anything you can do to kind of predict, and it was, young son sort of not sort of, or breathing, so it would have been classified as one of the actual serious ones. And luckily, I had a guy from St. Juan's who knew it, because they can never normally find me either. So I was actually quite surprised they arrived straight away. And when we're speaking with Pete and Beverly, it's like, how do you get this knowledge of someone like 40 years of knowledge very quickly into a wider population of ambulance drivers, control center staff? And so the technology it's not AI, it's like that augmented decision-making ability. So what we're saying is then, is this just actually Pete Legraley's driving time? What could he do if you could increase the actual, if it's the 12-minute coverage, or actually just go a bit faster? So 12-minute coverage, or assume you can go 1.5 times the speed limit, you're covering most of the island there. So that's actually quite comforting, because the previous one was not under flashing blues, so it was standard times. But again, still, Sam and I, I've still got a bit of a problem. I need to come in. I'm not going to, as the guy before, was it Ricky said, I'm not going to point where I live, but safe to say it's in that top corner where all the good surf is. So visually, this was very good, but you see the coverage in the middle is very good, and you've got this sort of Venn diagram, the 3 shades of color. So each one of those 3 overlap on the sort of the darkest colors here. And this one can be covered by 2 of those points, and only the very lightest color is by the outlier. But when we looked at this in the office, very quickly then, you've got 3 overlaps that would actually be in the sea. So what happens if we do shift those north, and that way a bit, if we got full island coverage? It's like, don't know, but you would assume you have, but it seems we've got quite a lot of overlap in the sea. Given enough time, the next thing we do is actually plot the data points in here and see that as a percentage. Overlay this with the heat map, and what is our coverage? Are we actually getting 90%, or is it 80%? But the next, it does raise the ethical question, do you go for the highest density coverage, or do you give me a chance and some ones? So that's one for the wider masses there. Or does that affect the house price index? I don't know. But it was very interesting, I think, as Andrew said, is just talk about how interesting it was as you got into the data. And it's like you pull a thread and you want to keep going. But luckily, we did have to stop, and it was kind of here. So that's kind of what we were trying to say. So, and everything we did at the hackathon, what we did was enable the police to electronically close roads. So you can actually then do a term what's called geofence. So there's a road, you close a major road, which is relevant to the ambulances because they're often going to the road closures. You can see on that map, it would be overlaid with a road closure, and it can dynamically reroute the ambulance. And we also did sort of geofencing where you had one of Andy's mood orbs that actually changes color based on the location. So that could be an aftermarket product, or was just let the creative juices flow. And when the police saw that, they were saying, well, that's good for insurance companies. It was one of those things. There are many applications to this technology, but we just need to collaborate. This isn't a point solution. This would be built on APIs so that you can actually overlay it with the police data, with the road closure. That's everything we sort of did at the hackathon was microservices. Don't want to do sort of point solutions. So that kind of, you know, it's like that's the where you can get to. And I think when we showed this with Beverly and the ambulance guys, I don't think they'd seen sort of visually what that looks like for the current ambulance placements. So, you know, do we want to see more of that as an island, that we can actually back up the data, give Pete the actually chance, rather than saying, I need a fourth crew, the numbers are getting higher, back that up with some data and actually spend some more time over to the IBM guys to actually start refining, proving, and improving that model, which I think would be the sort of next logical step. So I think we've got just like 1 or 2 more slides, and then it's over to Jeff just to say sort of what the future could be. So, yeah, you can cover that one, Ben. It's fine. Yeah,
so this takes a bit of imagination, but once we've done all this like heavy analytics and we've built this model and it's now dynamic and it factors everything in, it's, well, how do you actually use that in the real world? So this we still need to talk about, but it's this idea of having that technology in real time, being able to influence decisions of the drivers. As Gary mentioned, that kind of domain knowledge that the drivers already have, we can't, you know, straight away jump in there and say you must follow the rules or you must follow what it's telling you to do. They still need to use their judgment. So that's why it's a decision support system as opposed to a decision system. What we can envisage is something along the lines of something inside the ambulance vehicle itself, helping to kind of almost manage the island like a chessboard. So we saw the places that we've established so far. If we take the approach or the view that we're going to keep to those 3 places, it's kind of guarding or safeguarding the island, especially when one resource comes offline, you then filter around so you've got that best coverage for that scenario. If we want to get more complicated, which may end up with the ambulances running around like headless chickens, you could have it completely dynamic and it would be constantly reworking and moving them around the island. But we've got to take into account things like toilets and food breaks and all those kind of things and the human resources in this process. So that's just to get you thinking about that end result. At the moment, they work strongly with the control room, who do a great job in managing the kind of a fleet of all the emergency services. So it's whether we can try and take some of the stress off them, or maybe we do want them to remain controlled, so you have that consolidated approach across the departments. But again, we would supply them with something which is catered for them to kind of manage the situation or override or include that kind of thing. So the next steps, as Gary said, so we want to move from the past. We're already in the present. I think this is what the future looks like. Being informed with this data, using the data proactively, as opposed to just saying that's a nice, pretty visual. We're trying to actually enforce change in the actual process itself. That's where you're going to see the real benefit. There's a lot of work to go, but I think working with IBM and the ambulance service and the data team at the health, we can achieve some great things. Thank you.